Chalamuthu. My metric number is A22A0694. Today I am going to present data description. Let's talk about information of data. Information of data encompasses two categories of variables. For an example, sex is a categorical variable and BMI, children, and charges are numerical variable. Secondly, variable of interest. These variables are essential components of descriptive statistics which play a fundamental role in quantitative data analysis and basic graphical analysis. Go to the scale of measurements. The scale of measurements for the variable sex is nominal, indicating that it consists of categories and is at the lowest level on the scale. Lastly, source of data. The source of data is discussed and highlighting the distinction between primary data sources, which are first-hand and aimed at achieving specific goals, and secondary data sources, which have been statistically analyzed previously. This information is crucial for understanding the nature of the variables and the sources from which the data is obtained. That's all from me. Thank you.
Hi, I'm Keshan and my metric number is A22A0473. Now, I will continue with the second part, which is sampling data and decode categorical data. The process of choosing a group of people or things for a study in such a way that they continue a sample of the target population is known as sampling. In this case, BMI, children, and charges are the three sampling parameters which we choose that determine how the sample is displayed. The two methodologies that we utilize in this sampling data are non-profitability, known as non-random, and profitability, known as random. Two types of categorical data are used in this sampling, which is nominal and ordinal. Nominal data is the most basic type of categorical data. Categories in this nominal data simply represent different groups with no inherent order or meaning beyond their tables. Example include hair color, blood type, while type of categorical data maintains an order or ranking between categories. For example, it includes movie ratings, level of education, customer ratings, and more. Next, from the case study, 350 observations were randomly picked from 1339 data files. I used SPSS to find the data. We instructed to choose the lowest digit metric number of the group member for the further observation. The lowest metric number and with 02, which is Nitya Shree's one. Finally, we obtained 350 samples from 1339 data files as a result. So, these are one of the data sampling of our observation. There are three types of sampling parameters, which is BMI, children, and charges. Thank you.
Hi, I'm Yogesh Anbudhi here. So today I'm going to discuss about the numerical descriptive measures. So we're going to see the calculation of descriptive statistics. We got three elements, which is charges, children, and BMI. So first of all, for the charges, the end statistic is 349, range statistic is 50,058. Minimum statistics is 1,137 and maximum statistics is 51,195. Sum statistic is 4,811,684. Mean, which is statistics, is 13,787.06 and STD error is 666.928 and STD deviation statistic is 12459.248 and variance statistic is 155.232.860.59. So now for the children, end statistics is 349, range statistic is 5, minimum statistic is 0, maximum statistic is 5, sum statistic is 376. Mean statistic is 1.08 and mean STD error is 0.64 and STD deviation statistic is 1.188 and variance statistic is 1.411. And lastly, we're going to see the BMI. which is end statistic is 349, range statistic is 33, minimum statistic is 16, and maximum statistic is 49. Sum statistics is 10,696, mean which is statistic 30.65, mean STD error is 0.301, and STD deviation statistic is 5.618, variance statistic is 31.556. So the valid n is 349. So now we're going to see the calculation of the statistics, which is with the three elements: charges, BMI and children. Valid is 349 for the 3 dimension, and missing is 2 for the 3 dimension also. Mean for the charges is 13787.06, for BMI 30.65, for children is 1.08. STD error for mean, which is charges, is 666.928, BMI is 0.301, and children 0.064. Median for charges is 9644.00, for BMI is 30.00, for children is 1.00. Mode for charges is 1137, and mode for BMI is 28, and mode for children is 0. STD deviation for charges is 12459.248, for BMI is 4.618, for children is 1.188. Variance for charges is 155232860.59, for BMI is 31.556, for children is 1.411. Skewness is for charges is 1.362, for BMI 0.113, for children is 0.885. STD error of skewness for charges is 0.131, and BMI and children same as the charges. And for the range is for charges is 50058, and BMI is 33, and children is going to be 5. Minimum amount for charges is 1137, for BMI is 16, and children is 0. Maximum amount for charges is 51195, for BMI is 49, for children is 5. Sum for charges is 4811684, for BMI is 10696, and for children is 376. So now I'm going to talk about the frequency table for children, BMI and charges, and you can see the table over the slide. And the missing system for frequency is 2, and missing system for percentage is 6, which is same as for the 3 elements, which is children, BMI and charges. And the total value for frequency is 351, and the total percentage is 100, same as the 3 elements.
My name is Development. My matrix number is A22B1302. I would like to present about the graphical representation. The first graph is histogram of children. According to the histogram, the midpoint of the class 0 to 1 is 0.5, and the maximum frequency is 235. In addition, the midpoint of class 2 to 3 is 2.5 and frequency 104, which is the second highest frequency. Lastly, there are 10 frequency for the class 4 to 5, which is 4.5, serving as the midpoint. The second graph is frequency polling of BMI. Based on the frequency polling above, the midpoint of class 28 to 21 is 29.5 and has the highest frequency of 97. Furthermore, when frequency is 74, which is the second highest frequency, the midpoint 33.5 of class 32-35. Moreover, there are 65 frequency for class 24 to 27 and the midpoint is 25.5. Besides that, the class 36 to 39 has 58 frequency and the midpoint is 37.5. The class 20 to 23 has 27 frequencies and the midpoint is 21.5. Then there are 18 frequency for class 40 to 43 and the midpoint is 41.5. The class 16 to 19 has 8 frequency and the midpoint is 17.5. Then there are two classes have same frequency, that is 1. The midpoint of these classes 44 to 47 and 48 to 51 are 45.9 and 49.5. Last but not least is the pie chart. According to the pie chart, the most significant percentage for male is 50% and is the highest frequency is 178. The frequency from the female is 172 and the second highest proportion is 50%. Both male and female have the same percentage, which is 50% by different frequency. That's all from me. Thank you.
Good morning everyone, I'm Yondini Sasikumar and my metric number is 822800592. Today I'm going to present about the statistical analysis using software. Let's discuss about the hypothesis testing. Here we can see the one sample statistic table under hypothesis testing. The one sample statistic table includes the mean and standard deviation for BMI, children and charges. The mean of BMI is 30.5973 and the standard deviation is 5.61505 and the mean of children is 1.08 and the standard deviation is 1.190. Continues to that, the mean of charges recorded 13,972.0077 and the standard deviation is 12,622 and 0.59435. Here we can see the ANOVA table. The ANOVA table presents the results of the analysis of variance for the variable BMI. It includes the sum of squares within and between groups, degrees of freedom, mean square, F value and the significances. In this case, the P value is 0.660 indicating that there is no significant difference between the groups for the BMI variables. Besides that, here we also can see the correlation table. The correlation table shows the Pearson correlation coefficients between the variables BMI, children and charges. The correlation coefficient ranges from -1 to +1 with values closer to -1 or +1 indicating a stronger correlation. In this case, there is a significant positive correlation between charges and BMI, which is R is equal to 0.216 and the P value is smaller than 0.01 and a weak correlation between BMI and children, which is R is equal to 0.077 and the P value is bigger than 0.05. Continues to that, the scatter plot 1 shows the relationship between BMI and charges. The plot indicates a positive linear relationship between the two variables with a Pearson correlation coefficient of 0.216. While the scatter plot 2 shows the relationship between BMI and children. The plot indicates a weak positive linear relationship between the two variables with a Pearson correlation coefficient of 0.077. And here for the part 5.3, we discuss the confidence interval table. The confidence interval table provides the lower and upper boundaries for the numerical variables, BMI, children and charges, along with the standard error and 95% confidence level. For BMI, the lower and upper boundaries are 30.0070 and 31.1876 respectively, with a standard error of 0.30014. For children, the lower and upper boundaries are 0.96 and 1.21 respectively, with a standard error of 0.064. For charges, the lower and upper boundaries are 12,645.0063 and 15,299.0092 respectively, with a standard error of 674.70605. These values provide a range of values within which the population parameter is likely to fall with a 95% confidence level. Here I am going to present the both prediction modeling and coefficients. Firstly, the prediction modeling is a statistical technique used to create a potential future states for entities based on data. In this case, a multiple regression equation was used to predict the dependent variable, which is sex category, based on the independent variable, which are BMI, children and charges. The equation is y is equal to 1.573 minus 0.004, which is the value of BMI, minus 0.003 which is the value of children plus 4.446 which is the value of charges. The coefficient represents the impact of each independent variables on the dependent variable, with BMI having a negative impact and charges having a positive impact. This equation can be used to predict the value of sex category based on the value of BMI, children and charges. For the coefficient table, it provides the under standardized coefficients, standardized coefficients, t values and significant levels for the independent variables which are BMI, children and charges in the multiple regression model. It shows that charges has a significant positive impact on the dependent variable sex category, while BMI and children have non-significant impact.
Greetings, Doctor. I'm Sharvina Mardamale. My metric number is A22A1147. Here I am going to talk about the concluding remarks. For this assignment, we have selected set data C to be analyzed. Set data C is about life insurance charges. We have selected one categorical data which is sex and three numerical data which is BMI, children and charges. It was necessary to convert the data from population size n, which is 1339, to sample size n in connection with the assignment requirements. To modify the numerical variable into a sample size of 349 from the first 351 cases, we used SPSS statistical software. We also used numerical descriptive measures in this assignment as well. As a way to perform these numerical descriptive measures, we chose to convert three numerical data sets such as BMI, children and charges from ungrouped to group data. For the numerical variables of children and BMI, we selected a histogram graph and frequency polygon, while a pie chart was used for the categorical variable of sex. We use the formula of 2k greater than n to decide on the number of classes and to determine the class interval. Based on the formula, we can figure out that there are 3 classes for the selected data for children. Meanwhile, there are 9 classes for the selected data for BMI. The class interval for children is 1 and for BMI is 4. We used SPSS software to perform the statistical analysis for the last section. ANOVA tests have been conducted for the variables of BMI, children and charges in order to test our hypothesis. We also used Microsoft Excel to double check our calculations. We found that a broad range of numerical descriptive measures are included in the SPSS results. In this section, we successfully built a regression model in the manner shown below. Y equals to 1.573 minus 0.004 minus 0.003 plus 4.446.